Okay, so here we are, chapter 4. In 4.1 we're classifying triangles. Okay, be careful. New vocabulary. Make sure that you've got all the vocabulary understood. What does each of those mean? Acute triangle, all angles must be less than 90 degrees. Equiangular, don't forget, most of you guys turn around and say equilateral, but equiangle means that all angles are the same, in that case 60 degrees. Obtuse triangle, one of your angles must be greater than 90 degrees. Right triangle, obviously one of your angles must be a right angle. Okay, now we're talking of sides. The first four were angles, now we're looking at sides. Now we've got equilateral, which means all three sides are the same. Isosceles, two sides must be congruent, and finally scalene, none of the sides are equal. Okay, so here's diagrams of what triangles are. Three acute angles, three congruent angles, but in theory 60 degrees. One obtuse, so as long as it's greater than 90, 91 up to 180 will give you an obtuse. Right triangle must be 90 degrees. Again, keep an eye out for our little square at the bottom. Okay, so here's examples, classifying the triangles by the description. So it tells you in example 1 it's got to be acute, equiangular, obtuse or right. Okay, well A is all three angles are acute, so it's an acute triangle. Okay, B, don't forget, either you look for the little red box or the fact that you've got 90 degrees given you, so this one must be a right triangle. Okay, so let's have a look at question number 1, which is this guy. Just look for the first thing. The first thing, you've got a 90 degree, so question number 1 must be a right. Don't need to do any bother thinking of what the other three are, so just check that. Okay, you can have a go at question 2 and 3. Okay, now we're classifying triangles by their lengths, their sides. Okay, equilateral, don't forget we're looking for our little notation. Three sides must be equal, they're all congruent. Isosceles, two sides are congruent. The third one doesn't have, well, if the third one was, it would be equilateral. Two isosceles, two sides must be the same. Scalene, no congruent sides whatsoever. Look at question number 4. It's talking about triangle ABD, which is this guy. Okay, ABD, and as you can see, all three of them are 60 degrees, so they are equiangular. Boom, job done. Keep it simple. Classifying triangles by the sides, it's got to be either equilateral, isosceles or scalene. Make sure. Look at question number 7. Question number 7, we're looking for the notation. Look, two sides are the same or congruent, so this guy, isosceles. Okay, example 4. Now algebra comes into play, and looking at your notes as far as making statements. Okay, everything that they've done, they've told you what they're going to do and the reason why, so make sure you do. But look for things. Okay, it says that M is the midpoint of JL. So from here to here is 1.5, so part way, which is up to where M is half of that, so that's going to be 0.75. Okay, and then look for little nuggets of gold. So these two guys must be congruent, so which means that KM is also 0.75. Okay, so look for those little golden nuggets that you get. Let's have a look at number 9, FGH. FGH. So we're looking at this triangle here. Okay, look at what we know. For a start, we've got our little notation here and here, which means that GH must also equal 5. Okay, and FK must also equal 2.5 because it tells you that it's the midpoint. So we've got information like that. So you've got two triangles, you've got a triangle with two equal sides. And don't forget that it says that they're two equal sides, but you also know that if FK is 2.5 and KH is 2.5, then FH must also equal 5. So in theory, you've got three sides all equal 5, so it's an equilateral. Okay, finally, example 5. Again, find it. Now we've got a lot of algebra in here, but what we do know is that these two guys must be congruent. So you can set them to equal each other. You can find out what x is, plug it in. All right. Okay, so here is question number 12. Okay, so let's have a look at what we do know. For a start, we've got equals. So from straight away, we can then set up our equation. So 3x minus 4 must equal 2x plus 7. Subtract the 2x from both sides. So we've got x minus 4 equals 7. Add 4 to both sides, so x equals 11. First part of the answer, because it says find x, and then we've got to find a measure of the unknown side. So there, all we've got to do is plug it in. So 3 times 11 minus 4, well 3 11s is 33, minus 4 will give you 29. All right, in theory we've finished, but you know me, plug it into the other one as well. So 2 times 11 plus 7. 2 11s is 22, plus your 7 is also 29. Because these two guys are the same value,